about what happens when you have one side of your equation is raised to a power, and that power is a rational power. So when that happens, when that one side of your equation is raised to a rational power, that's actually really, really simple to undo. Now remember, it is a radical, but all you have to do when this happens is raise both sides to the reciprocal power. So let me show you what that looks like. So what I'm going to do is raise both sides to the reciprocal of this power. So the reciprocal of 3 over 4 is 4 over 3. I'm going to do that in red. So I'm going to raise both sides to the power of 4 over 3. That's really lovely because when I do that, I can use the power to a power property. These right here, I can multiply them and they become the power of 1. So I'm left with x plus 2, all of that to the power of 1. Why did I write that? That's not even there. Sorry. And now it's 8 to the 4/3 power. 8 to the 4/3 power is really not a terrible number. Let's remember what it means to be 8 to the 4/3 power. That is the same thing as taking the cube root of 8 and raising that to the power of 4. Well, the cube root of 8 is 2. So I can take 2 to the power of 4. 2 to the power of 4 is 16. Yeah, 16. Then from there, of course, I would subtract 2 from both sides, and x would be equal to 14. And that does check. I'm not going to check it for a time, but that is the solution. Okay, let's talk about inequalities because we have not done that yet. So I definitely want to do that. Let's talk about inequalities. Let's say I have 3 times the square root of x minus 1 is less than or equal to 12. 3 times the square root of x minus 1 is less than or equal to 12. The rules are exactly the same. Like, the first thing I always want to do is isolate that radical if at all possible. So obviously, let's do that. So from here, I would divide both sides by 3, and then I would have the square root of x minus 1 is less than or equal to 4. Same as before, I would take both sides, I would raise them to the power of 2 to get rid of that radical. So I have x minus 1 is less than or equal to 16. Add 1 to both sides, and x is less than or equal to 15. Now, 17. Sorry, 17. That's a 17. Now with inequalities, that is definitely something to consider. The other thing you have to consider is the radicand. So please don't forget that. What you have to do is take your radicand. My radicand is x minus 1. And you want to make sure that that's greater than or equal to 0. Because if I take the square root of a negative, obviously I'm going to get an imaginary number. That's not good in this particular situation. So I want to make sure that my radicand is greater than or equal to 0, which means x would have to be greater than or equal to 1. So these are my 2 situations that I need to fulfill. And what I would do is I would just take a little number line and I would kind of graph this out. So it says I need a 1 and a 17. So this could be 17, this could be 1. And I'm going to graph it out. So I have x is less than or equal to 17. So I would color this in and go this way. X is greater than or equal to 1, so we'd go this way, and I can see very clearly what my solution is. So it shows that x is going to be between 1 and 17 for my solution. So the biggest difference when you're doing inequalities with radicals is just to make sure you take that radicand, set that greater than or equal to 0, and that'll give you, and then you have to consider both intervals there. Okay, you could also write this, if you wanted to write this in interval notation, let me put that on there. That would be 1 to 17 inclusive. So if you wanted that in interval notation, you could do that as well. Yeah, it's just a little extra fun. Okay. Thanks for coming.